Okay, hello everyone. Uh, we have been discussing the topic on supplier selection, supplier evaluation. So always, such kind of decisions, they invite lot many factors to be considered, and so that one can arrive to some index or some score with the help of what we can rank the suppliers. We can then select the best suppliers. Okay, so to handle such kind of situations, sometimes we need some methods which are classified under multi-criteria decision making models. There are many multi-criteria decision making model exist, right? Every model has its own advantages and disadvantages. Okay, so one of them is called TOPSIS. This is technique for order preference by similarity to the ideal situation or ideal solution. Okay, so what it does, it can accommodate multiple factors which are also called attributes and criteria. In the last session, we have seen while selecting suppliers, we have to have many attributes or criteria. On that basis, one has to select or evaluate the suppliers. Okay, so how we can arrive to a composite score, because there are so many criterias, and at the same time we have many suppliers existing, who are eligible, who are qualified to supply the products. So which one is the best one when one has to evaluate, or when we have to select for many criteria or many factors. Okay, so with this backdrop, we will go through this tool. As I've said, this is a multi-criteria decision making tool, correct, which fits very well in the problem domain of supplier selection. The objective is to assess and rank various alternatives, and in our context, these alternatives are nothing but suppliers, number of suppliers, right, which are based on certain attributes. Now attributes, in the last class we have seen, it can be management capability, it can be quality related attribute, it can be delivery related attribute, right? So this set of attributes represent the factors that influence the decision maker's choice while prioritizing the alternatives. So this is the aim of the TOPSIS, right? It will help us in giving relative significance, because each attribute is rated differently by different organizations, right? Or it can be rated differently by different decision makers. Okay, so this method prioritizes the alternatives. The concept they use is the Euclidean distance. Okay, so we will see how they use this Euclidean distance, right? So the concept of TOPSIS is this: prioritize the alternatives, that is prioritize or rank the suppliers according to Euclidean distance. So the moment we say distance, means like, if there is some ideal situation or ideal solution. Okay, if there is a positive ideal solution, means like, if any supplier qualifies based on the criteria, if any supplier qualifies to be as close as possible to the positive solution. Okay, so that would be the best solution. At the same time, the longest distance from the negative ideal solution. Okay, so we, based on these two indicators, we would bring an overall index, okay, which will be determined using distances from ideal solutions. Okay, so what are the inputs required? Obviously we need some alternatives, that is, alternatives in our context can be suppliers. So what are the alternatives? S1, S2, S3, S4 can be the suppliers. This is the alternatives one can have to choose from or rank them, right? And at the same time, we have attributes, right? This is our A, and this is the attributes. So attributes can be quality, it can be delivery, and so on, right? So attributes will be, or factors will be, till J. Okay, so for each alternative we would be having some scores for the attribute. Okay, so this is the decision makers, like will be having different scores, right? If scoring scheme is 1 to 5, right, one supplier can get from, for factor 1 maybe 5, right? Another supplier will get 2, right? If it is scoring system is between 1 to 10, so accordingly one can consult the experts, right, in that area, so to rank them or to score them, right? So we need alternatives from which we need to select. We need attributes or criteria on what basis we are going to select. So these are the scores assigned by decision makers in the matrix, right? So what are the Topsis method steps we would use, right? Remember, we need ideal solution, right? And we need to find out two ideal solutions, right? One is best, another is worst, right? So that we can see who are the suppliers closer to best and farthest from worst. This is the concept. Okay, this is the concept of the Topsis method. Now to do that, what we can do is, so we will first take the decision makers which assign the scores and create a decision matrix. Like this is the decision matrix once we get the score. Now after getting the scores, one can object that probably somebody is giving score of 7 here, right? It might be like uh, there is a subjectivity, like in providing scores, like here somebody might give 9, right? So there can be a subjectivity of scores, right? Or one can question, like how the scores can be taken as it is, right? uh, unless we have something to normalize the scores, right? So to cater to the subjectivity, right, in this, because there's a lot of subjective judgment goes, like we get the expert's opinion, right, in terms of providing the scores. Okay, so it is very important first to normalize. So we will get the normalized performance ratings out of this decision matrix, and then we will get the normalized decision matrix. Now how to normalize for each attribute, right? We can get the score, right? Okay, when we will go to the step with the example, it would be more clear, right? So here the method we would use is that we will take the score, we will divide the score with the summation of square of the scores given to the all attributes. Okay, so we will see that as we will proceed with the example. The idea is first to normalize the scores. Okay, when we would normalize the scores, it is very important to have the weighted scores, because for any organization all the attributes might not carry equal priority. Okay, they might have different priority, so based on the priority we can assign weights so that we can get a weighted normalized scores. Then we will find out something to get the positive ideal solution and negative ideal solution. So what are the indicators of positive ideal solution, so that we can compare every possibility compared to the positive ideal solution. At the same time, we need to calculate the every possibility with the negative ideal solution. Okay, so that would be done. Then we will get the separation value right? So we will see that, which alternative has done well in terms of meeting this conceptual understanding of, TOPSIS, which supplier has been, more closer to positive ideal and farther to the negative ideal. Okay, so the separation value will tell us this, and then we will determine the overall performance score. Okay, so these are the steps we would follow. Keep in mind all the steps. Step 1. Let's do this with an example. If we are required to assess or prioritize 3 suppliers, that is 3 alternatives. So here in our context, this is a supplier selection problem or supplier ranking problem. We want to assess 3 alternatives, right? So what are the alternatives? Supplier 1, 2 and 3. And let's say we have 3 attributes: reputation, trust and on-time delivery, right? Now this multi-criteria decision-making models, they also give us one liberty, right? Many a times there are indicators like, which cannot be measured with the numerical numbers, like, we cannot measure them objectively. Okay, for example, your delivery time you can measure, right? When the delivery come, at what time, how many hours it takes or how many minutes it takes, we can quantify it. We can use the exact number to arrive to some score, right? But there are many indicators like trust, right? Whether the supplier is trustworthy, whether the supplier is dependable. So such kind of indicators are very difficult to quantify and, assign a number. So in such cases, one can take opinions of experts that, okay, on the scale of 1 to 10, where you rank them or what score you would like to give, right? Based on maybe past experience or based on the past performance of the suppliers. So those indicators can also be accommodated in MCDM methods, and so is in TOPSIS. So we will get the scores, right? Suppose, so between 1 to 10, the experts have given the scores. So we have got the scores, but we need to normalize, right? So for normalize, second step, we need to normalize it. So how we are going to normalize the score, right? Divided by, for this attribute, what are the other scores? Okay, so that would give, like, because this can be like given keeping the relative standing of suppliers. Okay, so such normalization would help us, to remove any subjectivity, right, while giving the scores to the suppliers. So for each cell, what we can do, we can take that score divided by the squares of the score for each attribute, take square root, and we will get, the normalized scores for each attribute for all the alternatives. Okay, so now this is a normalized matrix. We have got the normalized scores now. Okay, so now we have normalized the data here. Okay, now what is the next step? Next step is whether each attribute carries equal weight, whether for any organization is it on-time delivery more important than trust or reputation, or vice versa. Okay, so in that case, right, I need to consider weights. Suppose I give weights in this form, right? So if that is the case, I know the weights of each attribute. Now I would get the step 3, weighted normalized matrix, where I will multiply each normalized score with the respective weight of the attribute. Got right? So now I get the weighted normalized scores. Okay, so this is the step 3, weighted normalized score. right? So now what? Now our matrix is ready, which is normalized, which has captured the importance of criteria or importance of attributes. Okay. Now we need to go forward to find the positive ideal or negative ideal solution. So for that, what we will do, right? We have, all this. For each attribute, we have the weighted normalized score for each alternative or for each supplier, we can say. Now, out of this one, which one has done the best and which one has done the worst? That would help. So this is U. So this is, by the way, this is my U vector with, all the elements as Uij. So if this is Uij, means this is the matrix U, which is weighted normalized matrix. In this, I would like to find for each attribute which one is the benefit attribute. Okay, benefit attribute means which one is the best performer, right? So that Uij will be the U1 plus. Okay, that means for that attribute, I will get this one for first attribute, and then second, so on for all attributes I would get. Okay, so and when this cost attribute will come, what do we mean by cost attribute? Any idea? Pardon? Undesirable? Undesirable traits? Are they undesirable traits? Everyone is with this argument that this is the undesirable. If this is undesirable, then why we have to find the negative solution? Because undesirable thing will be covered in the negative solution. So what does this mean? So that definitely is not undesirable. Exactly. Less of that attribute is better. Okay. So what happens, like, if suppose in this course, right, I would say that the cost attribute, right, the lesser it is, the better it is. Lesser the better, right? If it is the cost one. So it is other way around. If I would say that lower the score, better, means lower the cost is better, right? In that case, TOPSes will accommodate that also. But in that case, rather than getting the positive ideal solution to consider max, one must consider min. Okay, right? Because, when you are solving a real business problem, there would be some performance indicators, magnitude wise or numerical value wise. Some would be more the better, some would be lesser the better, right? Like, your cost, the lead time, lesser the better. And if you would score like, lesser the better, okay, in that case, your positive ideal solution should be minimum value. Okay, so this is the advantage of TOPSes over many of other multi-criteria decision making model. Okay, so this is very important aspect here. The moment you will determine the positive ideal solution, remember that, right? So what is the maximum if it is benefit attribute, minimum if it is cost attribute, and you can determine the negative ideal solution, right, which should be minimum. If it is benefit attribute, it should be maximum if it is a cost attribute, right? So I hope you all are with me. Now here we have to find what should be the A plus we need to find out. For that, I need to get the set. What is the set? U1 plus. I need to get U1 plus. I need to get U2 plus. I need to get U3 plus. Right? So how to get U1 plus, which is the maximum Uij for the attribute. So maximum of this one will give me the A plus, and this will be U1 plus. Okay, so I will get U1 plus 1.98, right? And in the next is 2.68 and so on. We all are at same page? Okay. So we have got now. So now things are ready with us, right? Here we have computed positive ideal solution and negative ideal solution. Okay. Yes. Yeah, the calculation thing, you can do that, right? So this is, you will get, the positive and negative ideal solution has been determined, right? Now things are intuitively what we have discussed in the beginning. Now what our intuition says, we have ideal solutions with us now. Now what we are supposed to do? How far we are from ideal solutions. Okay, so that is easy. How far each cell is from the ideal solution and how far it is from the negative ideal solution, right? So this will be computed like that for each cell. This minus this square plus this minus this square, right? So we will compute that. That would give for each supplier, right, what is the separation value, right, using the distance measure will be there. Okay, so this is how we will determine the difference or distance between the ideal solution and the cell, right? And then what is the index? So index will be di minus divided by di minus and plus di. So this is more of a similarity, right? So we will use this index to consolidate our distances from the ideal solutions. Okay, and then we will find out the similarity, right? So after computing this one using our data from the separation values, we will compute that, and so the best alternative out of this thing is this one. So this is the best alternative, that's supplier S2, and the worst alternative is supplier S1. Okay, so this is how one can arrive. We can rank the alternatives, hence the suppliers. Okay, or we can select the best supplier, right, among many alternatives or many suppliers. Okay, so this is how we can use this method, right? This is a small example with 3 suppliers, right? But in reality, one can expand, like in multiple supplier situation. Okay, this is very much used, like in other industry also, right? Whenever you have any decision making situation to select a product, to select suppliers is one, but to select your financial portfolios, right? Or maybe if you want to compare some kind of credit risk or default risk, like so you have to predict in advance, like how the situation can go, like, maybe if you want to rate the customers for default risk or credit risk, you can use the similar kind of methods, basically where the decision making involves many factors, right? And all factors are important to be considered, and all factors carry different weightages, right? So those kind of situations one can use this TOPSIS. Okay, so this is all, because in the last class we have seen the weighted method to weigh the suppliers. Okay, so that method, we are simply adding the scores, right? So there in that method, right, the it can accommodate, like, which one is the best based on the weights given, right? But this method would help us, like, it's not only the maximum weight, how far that alternative is from the negative solution. Okay, so it's not only the closeness or the weighted positive solution, but it is also important to capture that factor should be far from the negative solution. Okay, so this is the plus point of having this technique over simple weighted average method for selecting the suppliers. Okay, we have just rated the suppliers, right? But as mentioned in the last session, that still, if we have to take further advanced decisions, like, how to allocate similar quantity or same quantity among multiple suppliers, right? Which one supplier should get how much quantity, right? And if we have to talk about multiple products, how one can do that, this can be covered in the advanced optimization models. So that we will cover in the next session. Okay, thank you.